Okay, today we are talking about writing, predicting, and balancing reactions. So basically in this first section of this worksheet that is found on Canvas, you are taking 8 word problems and you're turning them into chemical reactions, and then you're gonna balance them. So the first one is a little complicated, I'm not gonna lie. We did it in class and it was a little wild, but we got through it. So I'm just gonna walk you through the first one because I will not put one this difficult on your test. So we're just gonna work through this one, and then the other 8 are gonna be easier for you to be able to do on your own. So we're gonna start with number 1. Let's move this up a little bit. So it says when liquid isoprene, if it's something that difficult, I'm always gonna give you what the equation is for this worksheet's purpose. They listed it out for us. So we have C3H8O. It says it's a liquid, so you're going to indicate that with a letter L, plus oxygen gas. Oxygen is a diatomic element, so remember you need 2 of them. So it's going to be O2 and a G for gas. Because of this comma, everything else after that is a product. So it says it burns in oxygen gas. Gaseous carbon dioxide, dihydrogen monoxide, and heat are produced. So I'm going to put my arrow. Gaseous carbon dioxide, we have CO2 with a G, plus dihydrogen monoxide. This just goes back to when we were naming compounds from covalent bonding in the last unit. So di means 2, hydrogen. So we're going to have 2 hydrogens, H2, plus monooxide. Mono means 1, oxide is oxygen, so O. They could have said water vapor, but why not be complicated? And then heat are produced. Heat is just signified by the letter delta, or the triangle, okay? So what I like to do is I like to list them all out. So here I have carbon present, I have hydrogen present, and I have oxygen present. CHO, I got all of them. So on this side of the arrow, I have 3 carbons. On this side, I have 8 hydrogens. And then on this side, I have 2 oxygens, plus this one is going to give me 3. Okay? Here I have 1 carbon. Here I have 2 hydrogens. And on this side, I have 3 oxygens. Okay? So I'm just going to go down the list and start fixing them. I'm going to do this with a pencil in case I have to change anything. So here I have 3, here I have 1. The only way I'm going to get a 3 on this side is to multiply this by 3. So times 3. Okay. So we have 3. This is going to give, this is also multiplied by 3. So this is going to be 6, 7. And then this is going to, what is this? Hydrogen doesn't move, okay? So we have 3 and 7, and then, so our 3's check out. We're good for right now. Let's do our hydrogens. Here we have 8, here we have 2. So I'll do 4. 2 times 4 is gonna give me 8, but I also have to multiply this oxygen. So 4 times 8, I'm sorry, 4 times 1, it's gonna give me 1, plus this 6 is gonna give me 10. Okay, so the first one checks out, the second one checks out, and then we have this one. So based on what I have here, this is already going to be an issue because this is an odd number. There's no exponent out here to make it even. There is no number that I can multiply here by here to make it to make these equal. Even if I put a number like in this coefficient spot, it's always going to be even, and that's always going to throw me off. So what I'm going to do is I'm going to make this even. So what I'm going to do is I'm going to put a coefficient up here. So I'm going to pick a small one, so I have 2, and then I'm just going to multiply everything out. So 3 times 2 is going to give me 6. 2 times 8 is going to give me 16, and then 2 times oxygen, or times 1 is going to give me 2, plus this 2 is going to give me 4. Okay, and then just readjust as needed. So here we had 3, here we have 6. I need to change this 3 to 6. Okay, so 6. This is going to give me 6. 6 times 2 is going to give me 12. Okay, so we have 12. So this 6 checks out. Okay, now we have 16 here and what is this? 8. Okay, so we need to change it so I have a number here that matches it. So in order for me to get 16 hydrogens, I need to put an 8 up here. Okay, so we're going to change this. So 8 times 2 is going to give me 16. 8 times 1 is going to give me 8, plus 12 is going to give me 20. Okay, so here we have 6, here we have 16. This is also checking out. And now we just have to get 4 and 20 to be equal. So your first instinct is probably to put a big number right here. Just make sure you keep in mind this oxygen because you have to add that in here. So we need 20 on this side, but we already have 2 over here. So for this coefficient, think 20 minus 2 is going to give you 18. So you need something here that's going to give you 18. So because you have to multiply by 2, this is going to be 9. Okay, so 9 times 2 is 18, plus this 2 is going to give you 20. And that checks out. Okay, this one was a little complicated again. You won't get something this wild on your test. Okay, let's try the second one. I don't know if you can see it. So it says the second one is dissolved sodium hydroxide reacts with liquid sulfuric acid, H2SO4, aqueous sodium sulfate, liquid water, and heat are formed. So hydroxide, if you remember, is a polyatomic ion. Sulfate is also a polyatomic ion, which, remember, ion means charge, so we have to pay close attention to the charge. Okay, so we have sodium hydroxide. Sodium is going to be represented by the letter Na. Okay, I'm just going to write this out first and then we'll fix it. So sodium hydroxide is letter A, or Na. Hydroxide is OH. Hydroxide has a charge of -1. Sodium has a charge, if you remember from the periodic table, is +1 because it's in group 1. These equal out, so it works out for us. So we're actually going to be writing NaOH. We don't have to worry about adding another one so the charges are equal because they're already equal. Okay, so sodium hydroxide is going to react with sulfuric acid, H2SO4. Okay, sodium hydroxide is dissolved, so that means it's going to be aqueous. S2SO4 is going to be liquid, and it's going to create sodium sulfate. So sodium again is Na, sulfate is SO4. Sodium has a charge of +1, SO4 has a charge of -2. So you need to make sure that your charges match on each side. So you're taking this number, you're going to bring it down over here. This number is going to go over here, and you're going to end up with Na2SO4. Okay, so the swap and drop. You need 2 sodiums, so 2 positive charges to equal out this -2 charge. Okay, so that's going to be aqueous, so AQ, plus liquid water, so H2O. Okay, now we just balance it out. NaOH, and then oh wait, we already have an H there, and then sulfur. I realized I wrote it differently in the first one. Whatever you prefer. So here we have 4, 1, 2, 3. Sodium, oxygen, hydrogen, sulfur. Okay, yeah, we're fine. So on this side you have 1 sodium. On here you have 1 oxygen plus 4 oxygen, so 5. Hydrogen you have 3, and then sulfur you have 1. On this side you have 2 sodiums. On this side you have 5 oxygens. On this side you have 2 hydrogens and then 1 sulfur. Okay, so let's get to balancing. So here I have 1, here I have 2. Easy thing to do is going to multiply this by 2. This gives me 2 sodiums, which checks out. 2 times 1 is going to give me 2, plus this 4 is going to give me 6, okay? 2 times 1 is going to give me 2, plus this 2 is going to give me 4, okay? And then we still have 1 sulfur. So here we have 2, that matches out. Here we have 5, that does not match out. Here we have 2, doesn't match. Here we have 1. I'm going to do the hydrogens because the hydrogen is attached to an oxygen first. So by multiplying this, I'm going to create this number. I'm going to make it even, okay? So we'll try that first. So here I have 2, here I have 4. So I need to put a 2 over here to get 4. 2 times 2 is going to give me 4. 2 times 0, or oxygen, is going to give, oh my goodness, 2 times 1 is going to give me 2, plus this 4 is going to give me 6, and that matches out. Everything is good. Beautiful. Okay. Let's try a third one. Okay. So when fluorine gas is put into contact with solid calcium metal at high temperatures, sodium calcium fluoride powder is created. So fluorine is another diatomic element. So when we write it, it's going to be F2. It's a gas, so we're going to put a G. Is put into contact with solid calcium metal, plus calcium is Ca. Solid, we're putting our arrow to show chemical reaction. Solid calcium fluoride. So calcium is Ca. It has a charge of +2. Fluorine, F. So for when it tells you it's calcium fluorine, you don't need to automatically make this a diatomic element. It's just when it's by itself. But you still want to make sure that the charges are okay. So you're going to remember, fluorine has a charge of -1. These are not equal. You need an extra -1 charge, so you have 2 on this side and 2 on the other. So coincidentally, you will have CaF2, and it is a solid. Write everything out. So CaF, here you have 1 calcium, here you have 2 fluorines, and then on this side, you have 1 calcium and 2 fluorines. This is checked out. This is balanced. You don't need to worry about anything else, okay? So that's just what you're going to keep doing. Just pay close attention to the diatomic elements and the polyatomic ions. For the balance, you're just balancing the questions or the equations, and you're going to put the type of reaction. So remember, is it synthesis? Is it decomposition? Is it single replacement? Is it double replacement? So just look at what they give you and do your best. Remember, synthesis, you're taking 2 small elements and you're going to make them one big one. In decomposition, you're doing the opposite. So you have AB, and that's going to get broken up into something smaller. Single replacement means you're going to do a little switcheroo, but so here you have 3 elements. You're still going to have 3. One of them is going to be left out, just a different one. So you have AB plus C, and then double replacement. Ooh, C. D is going to give you AC plus BD. So you're just swapping it with a different partner than what you started with. Okay, we're going to talk about more the other 2 types of reactions, and we'll take like formal notes on these either today or tomorrow. Okay, and then on the back, basically we're predicting outcomes. So based on what they give you going in, you're going to try to figure out what's coming out looking at the different types of reactions. So like here you have Mg, here you have O2, making sure you're paying attention to the charges, because if it's a metal and a non-metal, you need to look at charge, okay? If it's 2 non-metals, you don't have to worry about it, okay? So we'll do a couple of these. So magnesium, Mg plus O2, magnesium has a charge of magnesium has a charge of +2. Oxygen has a charge of -2, but you have 2 of them. So you technically have a charge of a -4. So you need to make sure you swap them. So you need to have 2 magnesiums Ooh. In order for them to be equal, okay? Because here you have a positive 2, here you have a negative 4, so you need to add an extra 1 to make it equal. And then you just keep doing the same thing for synthesis. Decomposition, you're breaking them up. So here you have Al, aluminum and chlorine. So you're going to end up with aluminum plus chlorine, okay? And just make sure your equations are balanced. And just keep doing that for the rest of them, okay? Let me know if you need anything.